Matteo Pagani knows what to expect in Windows 10. He has authored several titles in Syncfusion Succinctly series of free technical ebooks. In this video, he guides you step by step through the code from the convergence path that led to Windows 10 to its cool new features.
Hello everybody and welcome to this introduction to Windows 10 for developers. My name is Matteo Pagani and I work for Microsoft as a support engineer for the App Consult program. Let's start and let's see what's new for developers in Windows 10, and let's start by seeing which is the path that led us from the first versions of the platforms to Windows 10. The keyword here is convergence, meaning that a while ago with the Xbox and with Windows Phone we have started to rethink and rebrand our platforms by creating new tools for developers, a new user experience and so on. However, in the beginning these platforms didn't have many points in common except for the approach with the user interface. With Windows 8, Windows Phone 8 and the Xbox One, things have started to change because we have introduced a converged OS kernel, meaning that the kernel of the operating system that runs under the hood on every platform is the same. However, in this release we still add differences when it comes to create an application. So Windows 8 introduced the new Windows runtime, while Windows Phone 8 was still based on Silverlight and on the .NET framework. With Windows 8.1 and Windows Phone 8.1, we finally introduced a converged app model. So the Windows runtime is now the fundamental base under both platforms, which means that you are able to reuse approximately 90% of the code and that you have the same app model on both platforms. However, we are still talking about two different projects with two different stores. So when you create a Windows 8.1 or Windows Phone 8.1 application, you still have to create two packages which needs to be submitted and maintained on two different stores. Windows 10 is the full convergence of this journey, meaning that now you have a single application, a single binary package that runs on every platform and is published on one unique store that run on every device which has Windows 10. And to these platforms we are adding new opportunities, like for example the Windows on Devices platform, meaning that Windows 10 is now able to run also on small devices and IoT platforms like the Raspberry Pi. Under the hood of all this new approach, there's the Universal Windows Platform. The Universal Windows Platform is built on top of the Windows runtime, so it's nothing new if you have already worked with Windows 8.1 or Windows Phone 8.1, but the most important new feature is that this Universal Windows Platform defines a common set of APIs and features which runs on every device which has Windows 10. So not just mobile like phones, tablets or PCs, but also IoT devices, consoles, the Surface Hub, which is a big touchscreen devices that is born for enterprise scenarios, and also holographic experiences. A while ago we have introduced HoloLens, which is a new holographic platforms which runs Windows 10 applications. So now we have a single store, a single SDK, a single set of services, but we have also access to different user interfaces because we are dealing with devices with different screens sizes, for example, and we have different user inputs because when you use a mobile phone you are interacting with touchscreen probably, while if you use a PC or a console or an IoT devices you introduce a completely different way of interacting with the device. This slide shows you how is the present. So right now when you create a universal Windows app for Windows 8 10.1, you create a new project in Visual Studio, and what you get is a solution with 3 different projects. One called Shared Project, which contains all the code and all the assets that you want to reuse in the other platforms, and then a specific project for Windows and a specific project for Windows Phone. When you have to deal with code that runs only on one of the 2 platforms, you have to use the conditional compilation, which means that the code defined into a conditional compilation block is compiled only if you are building the package for one specific platform. In this slide you can see an example. This code is interacting with the settings charm. The settings charm is a feature that is available only on the Windows, so this code is contained into a block if Windows up, meaning that this code will be compiled only if we are building the Windows project and not the Windows Phone one. The Universal Windows Platform instead introduces a new approach, since now it's a collection of contracts and extensions that are available on every platform. So you don't have to deal anymore with conditional compilation, because the Universal Windows Platform is the same on all of these devices. Another important difference is that now when you create an application, you decide to target a specific version of the operating system. So you create an application for Windows 8 or Windows 8.1. With Windows 10, instead, we are changing this approach because we will be able to update the Universal Windows Platform independently from the operating system. So, even if you are still using Windows 10, you can have different versions of the Universal Windows Platform. So, when you create an application, you will define which is the minimum version of the Universal Windows Platform you are going to support. If the user doesn't have an updated version of his operating system, so the mean version property is not fulfilled, the app won't be able to run on the device. With this new approach, as we have already mentioned before, we have one binary, so you don't have anymore to submit different binaries on different stores, but you have one single binary that runs on every device. So you don't have to use any more conditional code, and the store is unique, and this will help you as developers to maintain all your application in an easier way. However, we have said that the Universal Windows Platform is unique, but it runs on many devices, and all these devices can have differences, for example, in the way they handle input. How to achieve this scenario in a platform that runs on every device without differences? With platform extensions. Platform extensions is a set of SDKs that are available in Visual Studio and that you can add to a project in order to make use of features that are specific for a platform. Since these SDKs are built on top of the Universal Windows Platform, what happens is that these APIs are available on every device. However, if that device doesn't have support to a specific API, these features will be dummy features, meaning that the APIs will be there, but they will be fake, so they won't do anything. This will help you to be able to build the project independently if you are using one of these APIs or not, but these APIs won't work on specific devices. To manage this situation, since you don't have any more conditional compilation, we have introduced a way to test for capabilities. So instead of dealing with conditional compilation, you test if one of the APIs is implemented on the device, and you perform an operation only if this API is implemented. Let's see a small demo of how this approach works. So here I have a sample application. This is Visual Studio 2015 release candidate, which is the version required to create application for Windows 10. And when you install it, you will find in the new project page a new family of templates called Windows Universal, which will create application that runs on Windows 10 devices. In this application, I've simply set a message using a text block, but the interesting part happens in the code. So if we go in the code, you can see that we are using the API detection. So we want to do something specific, in this case show a message, when the back button is pressed. But the back button is a feature that right now is available only on Windows devices, Windows Phone devices. It's not available on a PC or on an IoT device. So what we are doing is that we have added in the references an extension which is called Microsoft Mobile Extension SDK, which gives access to specific features of the platforms that runs on mobile devices, and the back button is one of these. So after we have added this reference, we can subscribe to the back pressed event, which is triggered when the back button is pressed. And in this event, we just handle the event and show a message. However, we perform this operation only if the hardware buttons class is implemented, because if it's not implemented, this code won't work and will generate an exception. So we have defined the namespace of the type we want to use, in this case windows.phone.ui.input.hardwarebuttons, and using these new APIs we check if this type is present before subscribing to the event. The result is that if we launch the application on the local machine, meaning that the application will be deployed as a desktop application, so running on my desktop, you can see that the application runs just fine. So it simply displays a message, but it's working. It's not giving or raising any exception. However, if we launch the same app on the Windows 10 emulator, we can see that even here the app is running fine, no exceptions, but when I press the back button, I get the message because we have correctly subscribed to the back pressed event and we are managing the event handler. Let's get back to the slides, and I want to introduce you to one of the key features of when you work with a Windows 10 app, and this is one of the biggest changes for a developer that is coming from Windows 8 or Windows Phone 8. With Windows Universal Apps for Windows 8 or Windows Phone 8, it was quite easy to manage the differences between the platforms, because basically you had two different projects, one for Windows and one for Windows Phone. So in the end, you keep in the shared project all the assets or code that needs to be reused, but you create two different XAML pages for each platform. So in the end, you create two different user experience. Now instead, we have a single application that can run on a small phone and on a big television connected to an Xbox One. So we need to define the user experience in a way that is feasible for all these platforms. And the approach is that we are enlightening with new tools and new control is to create responsive apps. If you're coming from the web, this approach should be familiar to you, because basically it's a way to create applications that can detect the size change of the window, and they can respond, so that they can change the layout in a way that the content is still meaningful and readable for the user. To empower this approach, we have added the concept of visual state triggers. Visual state, it's not something new in Windows 10. Visual state, it's something that is part of the XAML, and it's a way to manage the different states that a control or more controls can have during the usage of the application. The biggest feature of visual state is that when you want to define the change from one state and the other, you don't have to define from scratch all the properties and all the templates, but you just need to specify which are the differences between the basic state and the new state. So for example, visual state is the way how the native controls of the platform manages the different interactions with the user. So if you use a button control, the button control has a normal state which defines its size and which defines, for example, that the background color is black while the text color is white. However, when the button is pressed, what happens is that the control switches to a new visual state called pressed, which defines just the differences with the normal state. So for example, it defines that the background of the button becomes white and the text of the button becomes black. Visual state are typically managed in code, so by using behaviors or by using the visual state manager, you manually define when a control needs to go from one state to another. Triggers are a way to handle the change from a visual state to another without needing code, so they automatically react to a condition. Built-in, we offer a kind of trigger, of visual state trigger, called adaptive trigger, which reacts to window size changes. So every time the window size changes, the trigger is able to change the visual state. But we are also providing a base class to implement your own triggers. So you can define your own custom events that should trigger a visual state change. Let me show you a demo of this approach. And in this sample application, I have defined a grid with a text block control. Nothing special here. The interesting part is that I have defined a couple of visual states, one called wide state and one called narrow states, and I'm using an adaptive trigger to define which is the minimum window width. So this code means that when the width of the window is between 0 and 600, this visual state will be applied. Otherwise, if the size of the window is bigger than 600, this wide state will be applied. And in the setters collection, we set which are the values of the properties of the controls we want to change. So in this case, for example, we are changing the value of the background property of the control called main grid, which is our grid. So what happens is that when I launch my application, for example, on the PC, you can see that the background of the window is green, but if I start to resize the window, it becomes red. And this is happening automatically without having to write any code. This approach is useful not just for managing the resizing of the windows, but also to manage the different form factors. So for example, all the code that manages the layout of this application running on a phone will be contained here, because the size of an application, of the window of an application running on a phone, will never be bigger than 600. So we can manage all the layout, all the phone layout here in this narrow state. To help you creating great experiences tailored on each devices, we are also offering you a way to have multiple XAML pages connected to one code behind. So the suggested approach is to use a responsive layout, because it's the best one to create applications that can adapt to different devices. But if you have the requirement to create pages that looks very differently from one device to another, we are adding a new template called XAML page, which is a way to create a XAML page which doesn't have a code behind the file. So it's connected to the code behind file of another page. So in the end you will have a base page with its code behind, and then you can have different XAML pages that are connected to the code behind of the original one, which are used when the app is running on a specific device. And this approach is achieved by using naming conventions. So you can have in your project some folders with the name device family dash the name of the platform you want to target. So for example, device family dash mobile, device family dash desktop. In this case, you will put the XAML pages in these folders, and when the app is running on one of these devices, these pages will be used instead of the standard one. To help you create great experiences, we are also adding a new control called the relative panel, which is very useful when you want to manage the responsive layout. The relative panel is a new panel where all the contents placed inside are arranged according to relationship between the controls and the panel itself, or the children controls, meaning that you can define, for example, that one control should always be below one other or left of one other, and this is very helpful to create applications that where the layout can quickly change according to the size of the window. Let me show an example to explain better what I mean. In this application, I have added 4 rectangle controls with 4 different colors, and all of them are inside a relative panel. And I'm using these relationships to define the position of these rectangles. So for example, I'm saying that the rectangle 2 should be right of the rectangle 1. The rectangle 3 should be below the rectangle 1, and so on. This way, by using the adaptive triggers we have talked before, it's easy to rearrange things when the layout of the page changes. So for example, let me show you the application and then I will explain the code so it will be easier for you to understand. When the application is running on a window which size is bigger than 600, we are displaying these rectangles using right of, below, and so on. But when I resize the window, they are automatically placed one below the other. And this is happening simply because in the other narrow state, I'm redefining the relationships between the controls. So if in the wide state they are placed one right of the one in right of the other one or below the other one, with the narrow state, I'm placing them all one below the other. And as you can see, it's very easy to achieve this kind of result. Without the relative panel, changing the position of the controls without using a relationships would be much harder. And in the end, we are empowering a new control called split view, which is used to create experiences similar to what is called hamburger menu. So a menu that comes from inside from one of the corner of the screens and that displays some content to the user to help them to navigate into the applications. It greatly adapts to responsive UI scenarios, and however, we are not giving you direct guidelines or constraints. So you can use it if it's needed. So if it fits the requirements of your app, you are not required to use it. And you can implement it in the way you want it, because as you can see in this slide, what the split view does is simply providing you a pane property which contains the content of the pane. So in this property you can add your custom XAML to define the content you want to display in the panel, and then you place the main content of the page. So it's up to you if you want to place the panel on the top, on the left, on the right, which content you want to display, and also the display mode. You have multiple display modes, so you can have a display mode where the menu goes over the content or shifts the content. It's up to you to define the best experience for your application. So what do I need to start creating great applications for Windows 10? You need Visual Studio 2015, which you can grab from visualstudio.com, and just make sure to do the custom installation and not the standard one, because by default the Windows 10 SDK and tools are not installed. And you need Windows 10, so you need to register to the Windows 10 Insider Preview program and start getting the previews of the operating system and install it on your machine until on 29th of July the final release of Windows 10 will be released to everyone. You can install Visual Studio 2015 and work on Windows 10 applications also on a Windows 8 computer, for example, but to debug and see the application running, you actually need a computer with Windows 10. So thanks for watching this video, and I hope I have helped you to understand better how to create application for Windows 10, and I hope to see a lot of great application created by you.
Thank you for watching the video. To learn more about the free Succinctly series of technical ebooks, please visit syncfusion.com/ebooks.